This is Ganesh. Hope the things are going good from your end. And today we are going to see about tree structure in ALV concept. And for this also we need a help of object-oriented methodology. As I mentioned in few previous videos, once you understand the design of any structure from the product perspective, then assigning a value could be very simple. So in the same fashion, I'm going to explain the design of the tree structure from SAP perspective. Then we'll just play around with the hard code values to understand how we can able to make a tree. And in the same way, we are going to assign the data as well. Same way we are going to assign the business data to the tree structure. Okay, so that is the idea of this particular session. Let's get into the slide. So the generic idea of tree designers look like this. So we have a parent node and it might have a child, more than one child also possible. And sometimes the same child needs to be act as a parent node because it has its own child. Okay, so the simpler. This is a very generic design of a tree structure. It might go depends on your business need. So once you understand your business need, how they want to make a tree, whether it have one parent and more child, or you have a parent, child, and you have sub-child, and you want to keep as a siblings, even in some method names also siblings for easy understanding. And we have an option called, okay, this is the first child of my parent, this is the last child of my parent, we have a sibling. So we have a lot of methods to achieve this particular tree structure. So with the help of a hard-coded value, not with the data, not with the business data, with the help of a very hard-coded value, we're going to understand how we can make a tree structure. We are going to play around with that. So once we are good with that, then assigning the data to the particular parent node or a child node or siblings is very simple. Okay. So the same way, this is for one particular data. I can say you can take an example of an order, operations, activities, and material description. It depends on your different business needs. So this is going to be a one exact record or records. And again, for the order, I can say this is for one particular order, and the second order is going to be the same one. So I have two different parent nodes, and we have a child, siblings, and subchild as well. So this is a very basic understanding of a tree structure in any format, or I can say in any platform. This is going to be the tree structure. So now we are going to understand what are the technical details is required from the ABAP perspective to make this tree happen with the help of a business data. Okay. The next one is we need an internal table. It's obvious. We need a data of an internal table, which is going to be keep the data for different nodes, parent, child, or siblings, whatever it is. Okay. The preferable way of your internal table is the final data or final structure of your internal table. Suppose you need a data from 3 or 4 different tables. So you know how to make a final internal table. Normally in ALV, we prefer go with the final internal table as a source of data for the ALV. The same way, you have to keep one final internal table ready to assign the values or data to the tree structure. Okay, that is very important. The reason behind is, if you take an ALV has one columns, right? Column headings. So material, order number, operations or activities, material, whatever it is. So for all the data, you have only one column heading. So little deeper, you can have a different column heading for different nodes. So parent, I want one column heading, child, I want one column heading. So maybe in this one, that is not going to be possible. That is the reason we prefer keep a final internal table for your tree node. Okay, so take the data from only from the final internal table. Okay, and that is the one. Another one is, so from this internal table, I'm going to decide, okay, I'm going to keep the first 2 columns as a parent node, and the data of column 2, 3, 4 from my internal table is going to be the child one. Probably 5 and 6 is going to be the subchild one. Okay, so that way you have to decide which column is going to be added in which node. Okay, that is purely depends on your own requirement. So technical wise, we are going to use minimum of 4 different classes from object-oriented ABAP. Probably this is very simple tree structure. Once you start adding an event and furthermore, probably you might require some other classes as well. Okay, so for this example, I need the base class is nothing but cl underscore salv. Most of the classes of for particular tree structure is going to be start with cl underscore salv only. Okay, the first one is salv tree. So if you say class, obviously you need an object reference. Okay, so you need to get the object reference of that. It's a very base class of your tree structure, ALV tree structure. And inside this, I'm going to have one more class for nodes. Okay, just get what is the nodes of, or simply you can say structure of the node. Okay, what are the columns to be involved? So you have to take the nodes object reference, and inside you need to have a one more called node. With the help of this class, we have a method called add node. Okay, these are very simple structure. We are going to use limited classes and methods. So add node is the method which is going to be the final one, which is going to be add the data into the particular node. Okay, so further we have to use a class called salv node. And the another one is clslv tree settings. Probably we are going to use this tree settings for the header on this session. What is the heading, the entire structure or entire output page, what is the page heading? And normally if it is a tree, you need a hierarchy. So what is the name of the particular column, the hierarchy column? So those things we are going to able to make it with the help of some few predefined methods, which is coming under salv tree settings class. Okay, so these are the four classes I'm going to use in this particular example. And another one, steps. What are the steps we are going to follow? The step one, there is a factory method inside the salv tree class. So with the help of the factory method, I'm going to receive the object reference of this salv tree class. Okay, so for that I have to just pass an empty it structure. Okay, this is going to be the internal table. That is the way it formed, the particular parameter of the method. So you have to pass your internal table, make sure it doesn't have a data as one of the parameter. Then you will get an object reference of your salv tree class. Once it is done, then you need to get the object reference of the settings class we have seen in the previous slide. For that you have to use a method called get tree settings. So it just get the reference of header settings. Okay, then you can use some other method to have a title of your heading, title of your page, title of the hierarchy column, whatever you want. Another one is nodes. That is also going to be part of this class only, tree class only. The method going to be get nodes. This is going to be receive the object reference of your nodes class. Okay, so get the node structure details. And final one would be once you receive that object reference and you have a method. Okay, this is wrong. It should be a single is enough because I'm using object. It's not a class. So single arrow is enough. And the method called add node. And there are some mandatory parameters, optional parameter if you want to pass a text to data, and what type of child, what is the relationship between the previous one and the current node. So those things are going to be passed as one of the parameters in the add node method. So these are the steps which we are going to follow to make a tree structure. So as I mentioned, I'm going to have a simple data which is going to be the production data. So I'm going to take aufnr and I'm going to take the operation number and aufpl. So only 3 or 4 fields. And before get into the content level, like data, business data level, I'm going to play around. I'm going to show you how to play around with the text to understand what is a parent, what is a child, what are the relationships are available, and then we are going to make use of the same thing with the business data also. So that is the idea of this tree structure. Okay, anything else? No. Okay, that's it. Let's get into the system now. This is my system, and let's do the declarations first. So I need internal table for holding my data. So that is going to be production orders. So AUFNR, and I need AUFNR, and then I need AUFPL, CO AUFPL, and final one is vornr. Type vornr. That's it. End of stup orders. So my internal table is ready. Body of an internal table is ready. So data type table of. Okay. Now I need the data reference, object reference for four different classes. The first one is for tree. It's a base class, right? So I can say base, okay, not base, I can go with tree. So tree type ref to cl s alv, sorry, type ref to cl salv underscore tree, and I need an object for nodes type ref to cl salv underscore nodes, and I need for node type ref to cl underscore salv node, and finally I need for settings. I'm going to use for it the header. So cl underscore salv tree settings. Okay, that's it. So this is a very basic settings for this example. Okay. Now the step one, I'm going to get the reference of object tree. So get the reference of object tree for this object. Get reference of this object. So further, I'm going to call a method under this particular class as factory. I'm going to call the factory method, and I'm going to pass this empty internal table as one of the parameter. Then I'm going to receive the object reference. Okay, and let's go to Control F6. So here I'm going to use class ALV tree, and the method is factory. I'm not going to give the instance here because after the output of this method, I'm going to receive the reference of it. So I'm going to call this method with the help of the class itself. So continue. And I don't want any exporting containers here. Is ALV. Always better you go with try catch, enable the try catch along with whatever informations you want, whatever the message you want. And here I'm going to receive the reference, and I'm going to send my empty internal table. Okay, and the additional information here, I'm not going to use a container concept. This is going to be means I'm not going to use a model pool here, just a report program I'm going to display in the tree. Same thing, if you want to display in the container, then you need like a screen, and you need a container in the layout. And that is the same thing whatever you're doing in the previous one, same thing we have to add it. Okay, so nothing big difference on that. So now I got the reference of my tree, then I can start working with settings, nodes, and everything. Okay, so let's start with settings first. So for settings, I need the reference. So what is the object? Settings. So that is available in a method called get tree settings is the method. From this tree reference get underscore tree, control space bar, yes, get tree settings. I got the reference now. So now you can call a method, whatever method you want to have the headings or title or tooltip, whatever it is, column heading, whatever you want, you can add it with the help of this object reference. So for the first one is, which I'm going to add as, sorry, the method name is set header, header of your entire output page. Okay, ALV Tree Samples. Okay, and then if you see the tree, the first column is going to be the hierarchical column with a arrow mark, so you can expand collapse, right? So that is the default column it comes, so you can set a name for that as well. So for that I need one more method called set hierarchy header. Yes, so this is going to be order hierarchy. So you can give any name and you can have a text symbols instead of hard coding. So just play around with other methods also. Maybe I can say set tooltip. Okay. Test. Okay. So we have few more, but I'm using only 3 of from this tree settings heading. Okay. It's good enough. Now I'm going to show you, because I have used, I have get the reference for object tree and object settings. Okay, let me get the reference for the node as well. Nodes, not node, nodes as well. So nodes equal to object tree, and the method is get nodes. Get underscore, and yeah, here it is, get nodes. Okay, so no parameter, mandatory parameters are required to pass. So almost we are ready. So nodes is, everything is going good so far. So I'm going to show you some hard coded values first. Then we'll assign the values to the particular node. Okay. So now what I'm going to do is, with the help of the reference, the nodes reference, I'm going to add a node. Okay. So object is add obj node equal to reference of nodes, and there is a method called add node. Okay, it has few mandatory parameters, so we are going to add one by one. Okay, the first one is relation node and the relationship. These two are mandatory one. So let me show you that. If you go to the add node method and go to class definition, add node parameter. So these two are mandatory. Related node you have to give, it's nothing but a key of the related node, and then relationship. So initial node, for the initial node, related node is going to be the empty. So because that is a first node, that's a parent node. Okay. And then data row is going to be the data, what kind of data informations we are going to pass. And the initially what I'm going to do is, I'm not going to do data row. Data row is optional. I'm going to use this text. So I want to show you, make you understand about the parent and child node. Then we'll play around with the data row. Okay. So relationship is nothing but what is the relationship of the particular node based on your previous one. Okay. So previous and the parent. So this is my first child, last child, siblings. So those informations are going to be added in this, in this parameter called relationship. Okay. So let's get into the code. The first one is related node. So here I'm going to use the first parameter, related node, and for the first node I'm going to keep this field as empty. So related node is going to be determined based on the previous node value. So here there is no previous node, this is going to be the first node, that is the reason I'm going to keep empty. And then second one, when we have to give what kind of value, we'll see in the next node, means the child node. While creating a child node, I will explain this relate node option. Okay. And the next one would be the text. So data flow I'm not going to use for this first particular scenario. So text is going to be my parent. So parent one, and relationship. So relationship field is a mandatory field, but for the first one I don't want to pass any relationship because this is not going to be a child, right? Because in relationship you have the option called relate child. I can show you that. There is a, what is that, ALV custom, one second. Okay, so this is actually GUI column tree. Yeah, so there is a class which has few relations like first child, first sibling, last child, last sibling, next sibling, previous sibling. But this is my parent node. So I'm not going to mention anything on here. So that is the reason I'm going to keep this particular field as empty, as this is a mandatory field. So that's it. I'm going to run my program. So this is a way we are going to add a node. Okay. So most of the work is going to be between loop and end loop. So here is a hard coder, so I mentioned do. Otherwise, normally we go with loop and end loop of our internal final internal table. Okay. Let's see how it display, and for that I need one particular method to be called. It's also coming under tree class, is going to be display. Simple. Okay, so display is the method name. That's it. Okay, so as per this code, I have only one parent node, but that is going to be repeated by 5 times. So 5 parent nodes. Then after seeing the output, we'll add the child node, then see how it reflects. Okay, activate and execute it. Okay, I think I missed one thing. 1 minute. So I didn't give the size of my hierarchy column, this one. So hierarchy column, I have set everything, what is the header, tooltip and all, but I didn't set the size. So settings, set hierarchy size, yes, it's going to be 10. Okay, I'll go with 20. Okay, activate and execute. Excuse me. So here you're able to see this is the order hierarchy, the text I have given, and this is ALV tree sample. This is the title of the page, and these are the fields which I have added: order, plan number, and like operations and activities. Simple. Okay. So I done with hard coded value parent 1. So 5 times the do worked. That is the reason you have 5 different parents. And I don't have any child added. That is the reason I'm not able to see the expand option. So by default, once you added the child, you will get a expand options for every node. So let's go to add a child for each parent. Okay. So go back. So to add a child, I need a value for a related node. To get the related node after this line, I need a small method to be called. So let me have a local variable. I can say this is my parent key. Okay. So for that, I'm going to use the reference is object node, and the method is get key. Okay, so this will receive the value of, normally it's a numeric value start with 1. It will receive the value of my parent key. So once it is received, I'm going to do, it's a copy paste, nothing big, just a copy paste, same kind of code I'm going to use here. But here the related node value is my parent key. Okay, and this is a hard coded one. I can say child 1. Okay, and it could be CLGUI column tree. It depends on your design. You have to choose which one you want. You can say this is my first child or first sibling, last child, last sibling. So whatever need. Okay, just I'm go with the first child. So that's it. Okay, nothing much. Activate it. Again, it's 5 times. It's a do. So it will create the child for every parent. So if I execute, see parent, and I have a child, parent, I have a child. So if you add a child for this one, the sub child or whatever terminology, so if you add a child under this, maybe I can say child 1a, then automatically you will get a expand symbol like this. It automatically comes in this child 1. Okay, so maybe for this parent 1, if you want parent 1, parent 2, you can do a concatenate index value, and you can do it just for your reference. Okay, and what I'm going to do is let me have one more child, like I can say siblings. So let's see the difference between the siblings and first child. Okay, so for that I need my child key. Okay, child key as object equals object node get key dot. Okay, so now I'm going to say this is coming under my child 1, child key. So I can say child 1A. So no siblings. Again, I'm going with the first child. So let me show you that. Then I will create as a siblings. Then we'll see what is the difference. So once you understand the design, then I'm putting a data into the particular line, particular child, siblings, everything is easy. Execute. So parent 1 and I have a child and child 1A. Okay, so it repeats. There is no difference. It just repeats it. So now what I'm going to do is I'm going to make my child 1A as siblings of my child 1. Okay, so siblings is nothing but it's going to be in the same level. So for that, let's go back and change this to my first sibling. Okay, activate and execute. Excuse me. Parent 1. So child 1 and 1A. So here you are not able to see the hierarchy because as per the code I mentioned, it should be my siblings. Okay, so this is a way you can play around with the relationship and automatically the design also will change. Got it? So this is a way to understand how the design for the tree structure. Once you are good with this design, now you can do the internal table and assign the values for it. So we'll see how to do that one. Okay, so now this is good enough. So let me keep it as, but I can say 1 equal to 2. I don't want to this do to be execute. So end, so end if. Okay, done. So now I'm going to use, so get node is anyway already there, tree get node, and I'm going to use the loop statement for my final internal table. I think yes, my final internal table is not ready. Okay, step 1. Okay, I missed it. Once it is done, then I can say step 2 for settings, header settings, header settings, and then step 3 for read the node structure, whatever we have assigned, and final step would be not final, maybe one more step to display. So step 4 is for data to ALV tree nodes, which node, parent or child, whatever it is, you have to mention it, and final step is to be displayed. Step 5, display the tree. Display the tree. That's it. So now I'm going to write the code to fill my internal table. So it's a simple one. Select aufnr and then aufpl. So it has both the tables. So I mentioned the name of the table and vornr from afko in a join afvc on afko aufpl equal to afvc aufpl, and it's going to be into table it underscore data. Okay, so here there is one point to be noted. Here the point is, we mentioned this internal table as a structure for ALV tree that we already assigned for the factory method. Okay, so if we use the same internal table in my loop and along with our add node, it just keep on appending the data to the same internal table. So that is a design, that is a structure. So what happens? You will get an infinite loop. So the idea behind us, use one empty internal table only for the structure level, and data probably you can have the another one. So data for tree type table of STU orders. So you can just check with this data using in a loop and try to use this internal table in the loop. You can see the difference. So you'll get an infinite loop if you use the same internal table which we used in the factory method. So I'm going to use ALV tree. Okay, another inter table basically. So data tree into WA data. So it's going to be the parent node first. So let me have the parent node, just a parent node. And here I'm not going to use text. I'm going to keep the text empty because I want to show you how the data is reflected in the ALV tree. Then we can go ahead with the text. So the parameter is data row and the values are available in work area WA data. Simple, nothing much. Add to order and execute. What is the error? I'm sorry, it's not declared. Data. Okay. Now it's good. Add to it and execute it. So here everything is apparent. I'm not having a text. That is the reason it's empty. Otherwise you can have a text over here and it's display like this. Okay. So we'll do small changes and we'll decide when the parent node to be generated. I can say whenever there is a change in the order, then I need the parent node, right? So it's very basic. Whenever there's a change in the order, I need a parent node. Whenever there is a change in the operation, I need a child node. So it depends on the business need. We can make a decision on that. So we have some basic functions over here, buttons over here. So it works actually. So click exit. I think it has more record. Let me have on 10 records. Otherwise it takes time for every execution. So now what I'm going to do is I need a text to be added. Let me have what is a data type or data element for this text parameter. Excuse me. So text would be okay, LVC underscore value. So data LV text type LVC underscore value. Okay, so now I'm going to write the text for my first node. Concatenate order number with the actual value of the order number into LV text separated by space. So here is going to be LV text. Okay, so just we are working on only the parent node. Add toward it and execute. So you have the text here. So order number, still I don't have the expand because this doesn't have a child. Okay, so order number and I limited with 10 rows. So it just displayed only the 10 rows. Okay, so now I'm going to add a child. So to add a child, I need a key for the related node. So let me take the key first. LV, I can say order key, just any name for understandable, you can give it here, and it's going to be the object node, and the method would be get key. Okay, once it is done, now I'm going to create my child here. Okay, so related node is good, nothing but the order key, the previous one. And okay, I'm not going with text, only data, and the relationship is child, so it's going to be the CL GUI column tree or LAT is going to be my first child. Okay, now just a child. Continue. It doesn't make any big difference in the output because it's just openly I'm just displaying all the data. So on order, so you'll have the order number. The same thing is going to be repeated here. Okay, and then the same thing. So I didn't mention on change of based on the condition. I didn't write anything. Simply I'm creating a tree with some data here. Okay. So now what I'm doing is I don't want to display this, right? I want for the parent node, I want only this part. I don't want to again display the order number, plan number or operations over here. So I'm going to disable the data row for the header. So exit. And what I'm going to do is I don't want this for my parent, only text is enough for me. Then I'm going to add a one condition here on change of whenever there is a change in my order number, then only then only this parent node should trigger. End on. Okay, so let me go with some 100 rows here. I have very limited data because it's a rental system, and then after that, once it is ready, that the remaining is going to be added as a child one. I didn't write any condition for a child, so activate and execute. So I have so only few these orders are available, and this order, so this is gone, and it will display all the related operations of that order. So here everything. And for this order, yes, you have, and this order you have this. Okay, so now we can write the some more code, maybe the child. So here if you want to text, you can write a text, maybe you can say operations. Okay, so let me go ahead and write a text for that. Concatenate operations data with vornr into the same variable I can use over here. You can use a clear statement separated by space. Okay, and activate and execute. So here just come to know order and operation 20, operation 10. So this is just an easy reference for the business to understand instead of going through. Suppose you have 20, 25 fields, but easy to identify with, like based on the unique values, you can have a text over here for that. Okay, so that is a way this will be easy for the business also to understand the record. So now I'm going to have one more child based on the operations. Okay, so let me have that first. So go back to the program. So here what we can do is I can switch the option here. Instead of operations, I'm going to keep the activity first, like this. So order is my parent, second child is going to be the activity, then I'm going to have the operations inside, because if we keep the operation as a first child, then you're not able to see the actual data, actual need of tree over here. Okay, so my parent is order number, my first child is activity, and then second child is, or the last child is operations. Okay, let's go back to the program. And so first child is going to be the activity now. So close this, delete it, activity, and this is going to be aufpl. Okay, and here what I'm going to do is on change of activity. So if any change in the activity, then I need this child to be enabled. aufpl. Okay, and close this block. End on. So I need a key for the activity. So activity and activity key. Okay, so object node. So because this activity key is going to be the input for the next one, next child. Get key. Yes, good. And now, okay, let me show how it's reflect. Execute. So order is my parent and activity is my another one, the first child. So now I'm going to introduce a child for activity. For this activity, what are all the operations? The code is not ready. That is the reason it just see only one record here. I'm going to add the code which is going to display all the operation under this activity. Okay. So for that, I have already retrieved the key field of the activity. So now I'm going to have the code almost same, but I don't want this key field because this is my last child, right? So operations. Okay. And there's going to be vornr. Yeah, that's it. And this is going to be the activity key. Activity key, yes. That's it. So text data is going to be the same, and relationship also. It's going to the first child, but it's going to repeat on it. Okay. And act about it. And execute. So I have the order number, parents, and I have the activity, and another activity I have two operations. The same thing for the next one, parents, activity, and it has all the operations. Okay. So this is a way you can design your tree, depends on your business need, and just play around with this and let me know if you have any doubts. We can implement whatever we have learned so far, like in what do you call interactive, or you can say events. I want, if I double click, I want, if I double click this or double click this order, it will take you to the actual order in a different transaction. So whatever it is, we have already saw that you have your set handler for the event, double click or enter, whatever it is, depends on that. Implement your event handler method, just write the code whatever is required. So just play around, and if you have any doubt on this, please let me know. Thank you so much for your time. See you in the next video. Bye.